All right, hello everyone. We are going to take notes on exponential growth and decay today. If you don't have a piece of paper and a pencil in front of you right now, I really need you to go get those things. So go ahead and pause the video and grab them. All right, now that we have everything in front of us, we are going to have to take notes on our own and write everything down. So if at any point in time I'm going too fast in the video, you can rewind, you can pause it, and write down what you need to. Okay, you can even listen over what I'm talking about. So if it doesn't make sense the first time, you can hear it again. It's the beauty of a video. All right, so the first thing we're going to talk about today is exponential growth. We're going to use exponential growth when our problem says increase. Okay, if it's saying something is increasing or getting larger or greater, we're going to use the exponential growth formula. And that formula is right there. The y equals p times the quantity of 1 plus r raised to the t power. Okay, so make sure you write down exponential growth and you write that formula right next to each other because they correspond with each other. And below that, you want to know what each letter represents. Okay, so y is the final amount. It's what I have at the end of my problem, at the end of the time that has passed. P is the initial amount. It's what I start with. And r is the rate of change of the decimal. When we give you r, when we give you the rate, it's going to be in a percent. So for us to put in our calculator, we're going to have to change it to a decimal. Remember that we have to move the decimal place 2 spaces to the left, and we'll do that in a problem. And then t represents the amount of time that has gone by. Okay, so make sure this is written down. If you don't have it written down, pause the video and get it down. Let's do our first problem. Okay? Do not write this whole problem down. Okay? Let's read it through, and then we'll just write down the important pieces of information. So in 1971, there were 294,105 females participating in high school sports. Since then, that number has increased on an average of 8.5% per year. Okay, it wants us to write an equation representing the number of females participating in high school sports since 1971. We don't have, so first, I'm using exponential growth because there's the word increased. So I know I'm going to be using that formula. Second, if I'm using that formula, let's pull out some important pieces of information from our problem. So we're looking for numbers. I have 1971. Okay, so you might want to write that down and say, the year by it. So you might want to write year, so you remember that's a year. And then we have this 294,105 females. That's the amount of females I'm starting with, so that's going to be my P, okay? It's my initial amount. So write that down and put a P by it or put initial amount by it. And then I have 8.5% per year. Because it's a percent, that is going to be my rate. Okay, so my R. So make sure you write that down with an R by it. So if I'm going to go write an equation, I'm using this formula. The first part of the formula is y. And if we remember, y is the final amount. However, I don't have a final amount. I only have a p. So we're going to leave y in the formula. So we're going to say y equals. And then the next part is p. Well, I know p is the 294,105 females. Then I have a parentheses, and I have a 1 plus. That 1 never changes. It's always there. And then I have r, my rate. Now remember what we said is that this has to be in a decimal, which means it's not supposed to have the percent symbol. So I know it's a decimal already, but because there's this percent symbol here, we still need to move this decimal 1, 2 spaces to the left. So remember we put a 0 in for a space holder. So this is what we should be using for our r. So right here I'm going to put 0.085 for my r. And I'm going to close the parentheses, and the next thing I need is a time, how much time has passed. Well, it hasn't told me how much time has passed. I just know the initial year was 1971. I can't put 1971 there because that's not an amount of time. That's just a label for a year. So it's 1971's the year. It's not the amount of time that has passed. So for right now, I just need to put a T here. So that's all they're looking for is just the formula with the information you do know put in. It's kind of like the setup of the problem. Because next, they're going to ask, how many females participating in high school sports the year 2001? So now I have another piece of information right here. It's the year 2001, so it's another year. Okay, so I have 2 years. I have 1971, which is my start year. I start in 1971, and I end in 2001, so it's my end year. So for me to figure out how many females are participating in high school, I need to be able to put a number here so I can put it in a calculator and get my final amount. Okay? Remember, T is time, so how much time has gone by. Well, if we're ending in 2001 and we started in 1971, all I have to do is subtract those two. When I subtract those two, it's going to give me the amount of time that has passed since the start of 71 to when I ended in 2001. And that is 30 years. So now this 30 is going to go where that T is. So I'm going to rewrite it. Y equals my 294,105 times 1 plus the 0.085. But now that 30 is going to go up here as a little number, an exponent. Now I can put this, all of this, in my calculator and get an answer. Okay? Now when we do that, you should still be able to do it on your phone because there is a caret button on your phone, the little upside down V. So let's type this in. That's a 294,105. Okay. Then I have parentheses 1 plus 0.085. Close the parenthesis. Now remember, to get that little number, you got to use the caret button, the upside down V, and I type in 30. I'm going to hit enter. And it's a really big number. It's 3,399,339.599. Okay, now here's the deal. We're talking about females. We're talking about human beings. And right now I have 0.59 of a female, of a human being. You can't have 0.6 of a person, guys. Okay, so when we see that, you have to still pay attention to what we're talking about in the problem. Okay, I'm talking about females, that's my unit, that's my measure. Okay, I can't have 0.6 of a female, so I'm going to have to make sure it's a whole number that I'm giving as an answer. So because this is a 5, and I want to make it a whole number, this number has to be rounded up. Well, the next number after 9 is 10, so that's going to change this to be 40. Okay, so my answer over here is going to be 3,399,40. Okay. 3,399. Oh, I missed a number. Sorry, guys. 3,399,340. There you go. So it's 3,399,340 females. Make sure you put units down. We're doing a word problem. Okay, so that would be our answer. So that's how we do exponential growth. It's essentially just figuring out what the pieces of information are, whether it's P or R or my T, and then putting it into the formula and just typing it in your calculator. All right, let's move on to exponential decay. Now, I use exponential decay when my problem is talking about decreasing. If it's talking about lessening the amount I start with, the word decrease or less than is in that problem, I'm using exponential decay. So make sure you write this stuff down. Everything that's on this slide needs to be on your notes sheet of paper. Okay. Now, exponential decay, the formula is exactly the same. The only difference is that there is a minus here. Because I'm decreasing, I'm getting less of an amount. I'm taking away from the initial amount. So I have to subtract instead of add. That is the difference between growth and decay. Growth, I'm going to have a plus sign between the 1 and the R. And a decay, I'm going to have a subtraction sign between the 1 and the R. Okay, and Y is still the final amount, P is still the initial amount, R is still a rate of change as a decimal, and T is still time. So I'm going to try a problem. If you need a couple more minutes to write this down, go ahead and pause the video and write it down, and then move on. All right, so we have this problem. Again, please don't write the whole problem down. We'll just write out the pieces of information that we need. So let's read it first. In 1950, the use of coal by residential and commercial users was 114.6 million tons. Many businesses now use cleaner sources of energy, and as a result, the use of coal has decreased by 6.6% per year. Okay, so the first thing I notice is that there's this word decrease, which means I have to use this formula. I have to use the one with the minus between the 1 and the R. So let's pick out some pieces of information. First, I have 1950. Now, that's not my T, but that is the start year. So let's put start year next to it. Okay, we started in 1950. Then the next piece of information they give me is 114.6 million tons. Remember, you want to write this highlighted information down and label it just like I did. Okay, so you should have 1950 on your paper with start year next to it. And you should have 114.6 million tons with a P or initial amount next to it, because that's what we started with. The other piece of information I have is 6.6% per year. Okay, because it is a percent, that is my R, that is my rate. And just like in the other problem, they just want us to write an equation that represents the use of coal since 1950. I don't have an end year, so I'm not going to put T in. All right, so keep that in mind. So the first part of my formula is a Y. I don't have the final amount. I don't have an end. So we're going to put Y equals. Then the next part is a P. My P we put as 114.6. And then parentheses 1 minus. It's 1 minus because, again, the problem said decreased. Then we need our R, our rate, which we labeled as 6.6%. Because it has a percent symbol, we still need to move this decimal 2 places to the left. So now I have 0.066. Close the parentheses. And again, I don't have an end year. This is just my start year, so I have to leave T there. I don't know how much time has passed. So that is the equation that represents. It's the start of my problem. It's my setup. And just like in the other problem, when we come down here to part B, and it asks to figure out the amount of coal that will be used in 2015, it's now given me another piece of information. This is my end year. And now I know how much time has passed. I can find my T by taking 2015 and subtracting my start year, which was 1950. And when I do that, I get 65. So my T is 65. I'm using the same equation I made in part A. So I'm going to put a little 65 here where the T is. Okay, remember that goes where the T is right there. And then I just got to type that in my calculator. All right, so we're going to pull up our calculator. All right, let me erase what I've written on here already. So 114.6, close, or hit a parenthesis, and it's 1 minus, because I'm doing decay, 0.066, close the parenthesis. And I need that little 65 as an exponent, so I have to hit the upside down V, the caret button, and I put 65 right there. And I hit enter. Okay, and I have a decimal, and I remember I'm talking about coal. So it is possible to have just part of a piece of coal. It's possible to have like half a piece of coal or a quarter piece of coal. Just like it's possible to have half a pizza, a quarter piece of pizza. Okay, so I'm going to leave the decimal. I'm just going to round to 2 decimal places. And if I do that, I look here, and it's less than 5. So all I have to do is cut this off, and this becomes my answer. So 1.35. I'm going to write that down. 1.35, and I need to remember my units. My units was 1 million tons. And there's my answer. So we went from using 114.6 million tons to just 1.35 million tons, which is significantly less. All right, we have one more problem to do. The only thing I'm going to tell you about this problem is it used the word depreciates. Okay, whenever we use the word depreciate, we're talking about decreasing the value or the starting amount. Okay, so we're talking about decreasing. So what I want you to do is I want you to pause the video. I want you to try this problem on your own. And remember, we're talking about decrease. This is supposed to be 10%. All right, pause the video and try the problem. All right, now that you've tried the problem, we're going to go through it and see if you got it right. So we already said that depreciates means decreasing. So when I see this word, depreciates, we're talking about decreasing, which means we're talking about decay. And remember, decay is the same formula as growth, but it's 1 minus R with a little t. Okay, so that's my setup. So I'm going to read through and pick out my important pieces of information in the problem. So a farmer buys a tractor for $50,000. Okay, that's my starting amount. That's my P. If the tractor depreciates 10% per year, so 10% per year, it's a percent, so that's my R, that's my rate. Find the value of the tractor in 7 years. In this case, they don't give me a year, a start year and an end year. They just give me the amount of years, which is great because that's just going to equal my T. I don't have to do any extra math. Okay, so I'm going to put everything in my formula. The first part is P, which is 50,000. And then I keep the 1 minus. And next is R. Remember, we can't use the percent. And when there is no decimal, it's always between the last number and the percent symbol. And I move it 1, 2 spaces to the left, so it goes in front of the 1. And then it told us our years. We didn't have to subtract our start and end year. We can just put a little 7 here because that's the amount of time that has passed. They told us. All right, and then I can put that all in my calculator. So let me erase this out. All right, so 50,000 is my start times 1 minus 0.10, close. And then I raise it to 7 and enter. And now my tractor is only worth $23,914.85. I can have decimals because now I'm talking about money, and money only has 2 decimals. So what I have to do is look at this number, and it's greater than 5, which means I need to round that number up, so it becomes 85. Let's write that down. My answer is $23,914.85. Okay, so that's growth and decay. Now that we're done with our notes, what I want you to do is I want you to go and do your homework that is assigned to you today. So go ahead and look on Google Classroom for those problems. Do them on a separate sheet of paper, and then make sure you take a good picture of all the problems and submit it onto Google Classroom. Okay? I hope you guys have a good day.